Bicarb reabsorption occurs in the nephron. About 80% of it is pulled off in the proximal tubule, about 10% in the thick ascending limb, about 6% in the distal convoluted tubule, and about 4% in the collecting duct. And I'd like to highlight here that you reabsorb all of your bicarb. You will not urinate any of it out in normal conditions. In the proximal tubule, let's now take this into a little bit more detail. How are you reabsorbing the bicarb? It's actually more complex than you think, because bicarb is a charged molecule. We don't have a specific transporter that's going to be able to move it across the apical membrane. So we have a little ingenious way of doing this. We utilize a transporter called the NHE3, sodium hydrogen ion exchanger, to kick out a hydrogen ion. It kicks out this hydrogen ion, combines to form bicarbonate acid. Carbonic anhydrase then converts it into water and carbon dioxide. So now you have water, which can be in the renal tubule, and carbon dioxide, which now can freely move across the membrane. It moves into the cytosol. You have a different carbonic anhydrase, which is the enzyme that helps convert this back to bicarbonate acid. So you have two carbonic anhydrases. Carbonic anhydrase 4, which is on the apical membrane, carbonic anhydrase 2, which is in the cytosol. This complex process, all it did was allow you to get a molecule across the apical membrane. Now, once you have formed carbonic acid, it once again can dissociate into a hydrogen ion, which then can be used to be kicked back out through the sodium hydrogen ion exchanger, and the bicarb can be reabsorbed across the basolateral membrane. So that's how you reabsorb 80% of your bicarb through this mechanism. Across the basolateral membrane, which is the opposite side of the apical membrane where the sodium hydrogen ion exchanger occurs, there's two different ways we move bicarbonate out of the cell. The first way to do that is by a cotransporter that involves sodium. The sodium cotransporter then allows for both bicarb and sodium to travel across the basolateral membrane, following the sodium gradient to move out bicarb. The second mechanism that you have to move bicarb out of the basolateral membrane is through an exchanger. This exchanger uses chloride, and chloride moves into the cell and bicarb moves out of the cell. This is an important process to think about because you need to now get the bicarb, which was in the cytosol, out across the basolateral membrane. So either co-transported with bicarb and sodium or exchanged for chloride.